In this video, we will start with exam style questions. You will find this on page 542 in the Namibian AS-Level Mathematics textbook, y equals mx plus c to success. Okay, let's look at the first exam style question. Prove that tan theta plus cot theta is equal to 2 over sin 2 theta. Okay, let's start there. Now, write it like this. Now, remember, when we did identities, we said sometimes you have to work on both sides, but let's start with the left-hand side. Take everything to sin and cos, okay? And now, make the denominators the same. So I times there, I can actually show you, it's sin, cos and sin, so I times there with sin theta, and I times there with sin theta. Okay, and that's why it's sin squared theta. There, I times with cos theta, and that's why it's cos squared. Then don't forget your identity. And that's 1. Leave it like that. Now take the right-hand side. Now, remember your double angles. Can you still remember the double angles of sin? Okay, so here is a printing mistake because I took it out of the summary of chapter 10. Can you see? Sin 2 theta is equal to 2 sin of theta or a, doesn't matter, a cos a. So there it must be cos theta, and then this must be cos. Doesn't matter which one. So basically, this will then be equal to this. So in the second print, I will make sure that I just correct that. So the left-hand side is equal to the right-hand side. Now, find the exact value of this. Now, you have to check that tan and cot, it doesn't matter what is, now I just put something in the place of theta. So, I can basically now substitute it by this. Okay, did you see there? And then as soon as I say 2 multiply 1, I get a quarter, and I go to my special triangles. Okay, and the quarter sin is opposite over hypotenuse. And then I multiply with the reciprocal, and I just get this. Okay, and then the next one, evaluate. Now, can you see there? It's again this. So basically, I put it still there in the place of that. I put that. Then I just multiply with the reciprocal. And then I'm getting this. And now I can go and I can integrate this. So it's sin becomes negative cos, but now because of the 2, it's actually 3 over 1 multiply negative a half. And that's why it's negative 3 over 2 cos. And then I just substitute. So I'm first going to substitute, I just want to see this substitution here. It's not theta, it's a half pi. There must also be a pi. Okay, and then, so it's going to be negative 3 over 2, a half pi. Now, let's just check this, and then it's 0. That is correct. So there's another printing mistake. Wow. Okay, so basically, if I'm going to say this was a half pi times 2, times the 2, then it's pi. So it's actually just becoming, now what is cos? Let me just take another color. What is cos pi? You have to think of your graphs. This is my cos graph. So, okay, so there at pi, there is 2 pi. It's going to be negative 1, and that's the reason why there is a negative 1. Okay, and a negative times a negative is positive, and cos 0, what is cos 0? It's going to be 1, and it's that 1. And then it's going to be 3 over 2 plus 3 over 2, and that's going to be 6 over 2, which will then give me the 3. And that's how I do that. Okay, I want you to stop the video, and just because it's more exam examples, although I think I did quite a lot of exam examples already, I'm going to do on this video number 1 and number 2. So stop the video, do it, and as soon as you are finished, you can continue the video. Okay. Okay, let's start with number 1. Show that. Okay, I start. So it's cos 2x plus 9 cos x plus 5, and that's going to be over cos x plus 4. Okay, now I must show that it's equal to identity to 2 cos x plus 1. Okay, now if I start with this one, I'm going to start again here, cos 2x. Now, because I have cos there, I'm going to see, because cos is having 3, do you see? No, that one is going to go to sin, so we're not going to take that one. Let's take the one that's keeping it to cos. Okay, it's a bit trial and error. If one is not working, then you try the other one. So in this case, I'm going to say 2 cos squared x minus 1, and I put it in that place. Can you see? So, and then I continue. So let's just go in, left hand side equals. So plus 9 cos x plus 5 over cos x plus 4. And now it's going to be 2 cos squared x plus 9 cos x. Okay, that, I don't know why that, I just want to quickly, that plus 5 didn't, the pen was not nice there. Okay, so it's going to be plus 4 over cos x plus 4. Okay, and now I'm just going to factorize. So it's 2 and now let's just go for 4. Let's just see, sorry. Okay, so make it 4 and 1 and 1 and 2 because it's positive, group A. So, no, 2. So that's going to be 8 plus 1. So what is 8 plus 1? It's 9. And then the signs are the same, plus, plus. And then cos x, cos x. So basically, I'm going to now get it, it's a quadratic trinomial. So I'm getting cos x plus 4. Remember, I'm looking at that cos x, the middle one, to help me. Just keep it in mind for number B. Plus 4. And I'm having 2 cos x plus 1. And that is going to be over cos x plus 4. And then I cancel. Okay. And then it's going to be 2 cos x plus 1. And that's exactly the same. I say it's equal to the right hand side. Okay, so in this case, I just had to work in 1. Don't be catch out by B. Don't always just go, oh, that's just repeating. Now, let me show you. Look at B. So hence find the value of, okay, that's pi, and that's negative pi. And now it's going to be cos, and look, I don't know if you see, that was 4x, that was 2x, that was 2x, and that was x. Okay, so keep that in mind. We'll see now how we're going to, I just want to keep my color. So cos 4x plus 9 cos 2x plus 5, and that is going to be over cos 2x plus 4, that is going to be 2x, integrate 2x. Okay, now, okay, so I'm going to change on this one. I will start first with this identity, the double angle identity. So if I change this, if I make it cos 4, okay, let's call it A, doesn't matter. And that will then be 2 cos squared, and then 2A, the half of this one, minus 1. And we did this in previous videos. Okay, so check how I change now everything. If I was starting, and I just want to show you what this would have then become. Say I was making this 4x, okay? This is what is in the question now. They have 4x, they have 9 cos 2x, okay? Are you with me? Plus 5 and cos 2x. this is what's now standing, oh, sorry, there, 2x, and there is 2x. That is what's standing now there. Now, how would it change here? I would have just said 2 cos squared, and now I would have just said 2x, okay? And that is going to be 2x from the beginning, and that is going to be 2x. I do exactly the same. I just have 2x, but remember this is now 2x every time, 2x, 2x, and this is 2x. Okay, and then I'm just going to get the 2x there, the 2x there, do you see? And then this cancel, and I will be ending up with 2x plus 1. Okay, so basically, that's the only thing that changed. So I can go, and look what I'm doing now. I'm still keeping my integral, and I say 2 cos 2x plus 1. Okay, did you see what it will be equal now? And dx. Right, so it's actually just that x that changed to the 2x on the other side also. And there was a 4. Okay, and now I'm going to integrate. So if I'm going to integrate, I'm going to get the following. So it's going to be 2, and then it's going to be multiply, this is integration, a half, and then it's going to be sin 2x plus x. And that's going to be 2 pi and negative pi. Okay. And now I'm just going to simplify this, because that is going to become 1. I think in my teacher's guide I made a mistake in the first print there. I will just correct it in the second print. Okay, because it must just be 1. It's multiplying out. The answer is correct, but that was because I'm multiplying with 0. And it didn't have the influence then. Okay, so I'm going to then put it in. So it's going to be sin 2 pi plus pi, that's in my first one, minus, in my second one, is sin 2 negative pi plus negative pi. Okay, now I'm going to quickly draw this graph for you. And can you see I'm going to negative 2 pi? You can do it, you know chapter 4. Okay, but let's first draw this. Okay, now what is, okay, actually I should have made it a bit, but it's all right. I will just make it shorter. If you have sin there, okay, and you continue with it on this side, I think it's a bit, as I said, it's just a rough sketch. Okay, it's just rough. That's why I said it was not a little bit longer. Okay, so this is pi, this is 2 pi, this is negative pi, this is negative 2 pi. There's your sin graph. So don't always just think of the positive, think also of the negative. You have everything. So sin 2 pi, that's there. And what is that going to be? 0. Plus the pi, just the pi on its own, minus, okay, and now this is going to be sin 2 negative, but that is going to be, again, 0. Not negative, it's just 0. And then, don't forget, a negative, okay, this is becoming a negative, do you see? Times that negative, and it's going to be plus pi. And that pi plus pi is 2 pi. And that's how I do it. Okay, not so difficult. Okay, I want us to do the next one, and that is number 2. So let's start. Let's just make space. So here it starts. Okay, here. Now I have enough space. Okay. Let's start with number 2. They say express, and they help you. And it's actually already, I did that on page 5 to 7. You can go back to page 5 to 7, but I will derive it again. So They say express cos square x in terms of cos 2x. It's really, and we did videos on that, it's really not so difficult. So we can just derive it. So I'm going to start again with this identity, this. So I'm going to say cos, and I will derive it again. Otherwise, you can just see I did it also on page 5. Sorry. Let's just write it correct. 527. Okay, but I'm going to derive it again. So cos 2x. According to the identity, it's 2 cos square x minus 1. Okay, now make cos square x the subject of the formula. Then it's going to be cos 2x plus 1. And there was a 2 still. Then I divide by 2. So therefore, cos square x is equal to a half cos 2x plus 1. Okay, let's start with number b. So it's going to be a third pi and 0, and then cos square x dx. Okay, and I must, they say, show that it's this answer. So I just start here. Now, that is the reason why they let me do this, to help you. Usually A helps you in B. Okay, so let's keep it pi over 3, 0. And now I'm just going to multiply it already in. So it's a half cos 2x plus a half, and that is going to be integrating to x. Okay, now I'm going to integrate. So it's a half, multiply a half due to that, and then sin 2x plus a half x. And it's pi over 3 and it's 0. Okay, and let's continue. So that is going to be a quarter sin, and I substitute pi over 3, plus a half pi over 3, minus a quarter sin, let's just get the pen correct, sin 20 plus a half 0. Okay, so always don't just think everything becomes 0. No, substitute it in, especially now with sin and cos and ease, something will happen. Okay, so this is now a quarter. Now this, and I'm going to show it to you on this side, this is sin 2 pi over 3. Now, you can go to that unit circle with the special angles on page 443, and you can find the answer there. But if you're not, I'll show you quickly what you do. You keep to a third, but you think, so it's two things that you do. You're first going to find sin pi over 3. Now, to find sin pi over 3, I'm just quickly, and I'm doing it so many times, I'm just quickly going to construct this table to you. So this is going to be 1, this is going to be, let's just get the pen correct. This is going to be, still the pen. This is going to be 2, this is going to be square root 3. This is 60 degrees, but pi over 3. This is 30 degrees, it's pi over 6. Okay, so sin pi over 3, sin is opposite over hypotenuse. So I know that that is square root 3 over 2. This just tells me in what quadrant. So, because I know 2/3, I know this is pi. So 2/3 is going to be in this quadrant. I think of my cos diagram. I think, what is sin there? Sin is positive, because that angle is pi over 3. Okay, so this 2/3 is just telling me in what quadrant, and because it's in sin's quadrant, that's why it's positive. Okay, but now I'm just going to fill it in, go back, and I'm filling in. So it's going to be square root 3 over 2 plus pi over 6 minus. Now, I have so many graphs, but sin 0, you already know that. What is sin 0? It's starting there, okay? So it's minus a quarter, and sin 0 is 0. And now, and this is also becoming 0 because it's multiplying. Okay. So I'm having, my final answer is square root 3 over 8 plus pi over 6. Okay. So let's see. Square root 3 over 8 plus pi over 6. And that's what they said I must get. Okay. I want you to show number C. Let's do number C. Now, at number C, I'm just going to make space here. Okay. And do it here under. Now, at number C, they say, by using an appropriate trigonometric identity, deduce. So you can go from scratch, and you can go, and I'm going to do C here, and I'm going to give it another color. You can go from scratch, and you can go say, okay, I know, but that's not what they really want. Although they will not penalize you, I think. You can go, I said, oh, I know that sin square x, I saw it on that page 5 to 7, is equal to a half 1 minus cos. It's just having the minus 2x, where the other one is having. And I can substitute, and I can do the log. But that's not what they want, really. They want you, that B helps you. Okay, now what is that meaning? They want you actually to use the normal identity that you know that sin square x plus cos square x is equal to 1. So, sin square x is equal to 1 minus cos square x. Okay, that's what they want. Because you already worked out cos square x. So, actually what they want. But I said you can do that, but what they want in this question, I'll show you. They still have a third, so pi over 3 and 0. And they have sin square x, and they have dx. But they want you actually to say that, okay, I'm going to use my identity, this. So it's going to be 1 minus cos square x dx. And then I can break it up into pi over 3, 0. Sorry, my 1 is not looking nice. 1 minus pi over 3, 0 cos square x. Because I have this answer. Then I just have to still find this one. So I can substitute this answer in there, that answer. Okay. So basically, I can just finish this one and say, okay, this is 1, so it's going to be x, and it's pi over 3 and 0. And now I'm going to substitute, keep your bracket, so it's square root 3 over 8 plus pi over 6. And if I'm continuing with this, I'm just going to say, okay, if I substitute, let's just get that correct, it's pi over 3 minus 0, okay, that's all, minus square root 3 over 8, minus square root, square root, listen to me, minus pi over 6. Okay, and now, what is 1/3? Because this is like terms, do you see that? So, what is 1/3? That's basically what minus 1 over 6. So, 1/3 minus is just going to be 1/6 pi, or pi over 6, doesn't matter, minus square root 3 over. And actually, that is the way they wanted you to do this question in the exam. But as I said, I think if you do this other method, you will get the same answer. I don't think they will penalize you, but I cannot say for certain.